Hello everyone. So this is going to be my first video in YouTube. Well, apparently first video because I did post something some 7 years back, some testing video. But from now on I'll be posting videos on projects that I'll be working on. वैसे वैसे तो मैं एक फुल टाइम एम्प्लॉय हूँ और कंसिस्टेंटली वीडियो अपलोड नहीं कर पाऊँगा, बट आई विल ट्राई टू कीप द फ्लो. This time I'm going to build one amplifier, and this is basically going to be 2-channel amplifier, and well, the bass component I'll have it in a separate video, like a separate project, which will only cover the subwoofer part of it. But this will only have 2 woofers and 2 tweeters. So I basically have this high quality woofers that I ordered from one contact that I got in some YouTube videos only. I'll drop the contact in the description. This is basically a 5-inch JBL woofer, which is like these are all rubber surroundings, and it's quite a good quality woofer. So 2 of this, and I am having 2 tweeters of Pioneer. This are also from the same person from whom I've got this. So these 2 are 8 ohms. I don't know if it can focus or not, but yeah. So this is 8 ohms, 15 watts, and this is 8 ohms, 40 watts. So yeah, so this is going to be the lineup of it. 2 tweeters for the high frequencies, 2 woofers for the mid bass and the mid range. So now I have some weird idea for it. So what normally people will do this for this lineup is basically we have 8 ohm 40 watt woofer and 8 ohm 15 watt tweeter. So for this, what generally audio people will do is they will pick up an audio amp which is say some 50 to 60 watts clean wattage of output, and they will have the output, suppose plus and minus here. They will hook up the woofer to it. I'm considering that it already is having the preamp before, or else we'll have a crossover in here, but I'm not using a crossover in here. I'm just assuming that it's already having one preamplifier. So this is the 8 ohm 40 watt woofer CW, and this is the negative contact of it, minus plus, and this they are going to feed with a capacitor, and this goes to the tweeter, 8 ohms 15 watts tweeters. This capacitor calculation is very easy. It's basically the normal high pass filter calculation. It's F is equals to 1 by 2 pi RC, and here the frequency is basically the cutoff frequency at which you want the tweeters to start acting. So basically normally the tweeters range will be from 1.5 kilohertz to 3 kilohertz. For me 2 kilohertz is the best cutoff frequency for the tweeters, and R is, we know, it's 8 ohm. Well, 8 ohm is not the resistance of the tweeter. It's basically kind of an apparent or an ideal condition calculation, because no tweeter is basically a simple resistor. It's kind of 8 ohm is basically the impedance of it. So it will behave in a different way. It won't be 8 ohms in all the frequencies. So in different frequencies it will have inductance and capacitance also acting on it, so there will be reactance on it. So but for ideal condition we'll just take R as this, so we can easily calculate the capacitor. Normally the capacitor range will be 2 microfarads, all ranging all the way up to 10 microfarads. So this is how it works, but I am having some different idea. So what I'm going to do is I'm going to have, suppose, the Bluetooth or the aux module in here, which is going to supply to one preamp. This preamp is going to deal with mid bass and mid range. Mid range is basically the vocals. This is going to get fed to one stereo amp. This stereo amp is going to be, say, 40 watts plus 40 watts of clean RMS power, and this is going to drive the woofers. Now I'm again going to take another output from here, and there is going to be another preamp. This preamp is only going to deal with high frequencies, and this is going to again get fed to a stereo amp, and this is going to be, suppose, 15 watts plus 15 watts. Yep. And this is going to get fed to the tweeters. So this is going to be my lineup, and I'm going to have separate preamps for separate drivers in here, because I want to keep the controls separate. Normally in market आजकल क्या हो रहा है कि ज़्यादातर जगह पे it's only class D amp are being used, maybe a TPA 3116D2 IC, which is the most commonly used IC, which is having 50 watts plus 50 watts for the stereo out, and 100 watt output for the subwoofer or the bass. This is full 2.1 channel, or there are many other class D amps, but I'm not really fond of class D amps. I have already designed one big boombox with this module, but this time I'm going to try with class AB amp.
Oh my god! Wow!
This is much better sound quality. I know these are very bad in efficiency and all. This is already having some 80 to 90% efficiency, but here, God, this is very bad in efficiencies. And suppose you are going to output something like this 80 watts, so the power that you are going to need or get from the AC in is somewhere near to 200 watts. So this is the power you are going to feed to get output, clean output of 40 watts. I know it's very bad in terms of efficiency, but the quality factor of the sound is much better than class D. There will be much clarity in the sound that you are going to produce, and if you are into audio for a long time, you'll be able to recognize the difference. Actually, there's a huge difference in the sound of class D and class AB. Like you can easily understand the sound differences. Now there are many ICs which are available for class D amps, and if I say, I have mostly in my mind to use this ones. This are basically, if I show you, these are basically LM3886 ICs. I don't know if it can focus or not. Yeah, so these are LM3886 TF models. TFs are basically because of the plastic tab here. So these are original ones. When I'll be making the circuit, I'll give you the link from where I've got these things. These are now very costly in the market. These are like some people are ready to pay thousands of rupees for these ICs, and either I'm going to be using these ICs, this LM3886. These are capable of 60 watts easily, provided there is a range of supply which you have to supply to get that much output. Or I'm going to use, and I'm talking about the woofer section here, where I need 40 plus 40 watts of output. So either I'm going to use this, or I have ordered some, this two you ignore, last two ones. The middle fours are LM1875 T ICs. These are original LM1875 T IC. Again, I'm going to keep the numbers of the people from whom I have purchased in the description in the videos when I will be making the circuit for those. Not now, not in this video, but yeah, this are again original LM1875 T ICs. These are also capable ICs, and I'm planning to bridge these two ICs to get the desired close to 40 watt output. And I'm also having this board here, which are having the original TDA 2030A ICs from ST Microelectronics, and I have bridged this to get the more output. I haven't tested it yet. I am yet to test it. I have made the circuit long back, and yeah, it's like star ground and all is taken care in here. I have to test it though, but I don't know how much output it's capable of. But yeah, for the tweeters, I am going to use this boards. I think they are capable of easily 15 watts output. These two are the UTC TDA 2050, UTC 2050s, and they are counterfeit of original ST Microelectronics TDA 2050 AI, not A, basically TDA 2050, only TDA 2050 ICs. And this UTC is basically a better quality Chinese counterfeit of these ICs, which do not just pop out whenever you power them or short circuit them. These have quite good capabilities of driving like at least 15 watts. I feel it can easily generate, though I'm yet to test it. These boards are having proper star grounding and small signal ground and the large signal ground separated. The layout is proper. This boards also I have purchased from the person from whom I have got this original LM1875T ICs, and also the UTC TDA 2050 ICs I have got from the same person. I'll definitely keep the number of this person. He's a great guy. He'll also suggest you a lot of things if you're building something up. So yeah, so we are going to design the circuit, make the circuit, and test the circuit. So for testing, I am going to be using the this function generator, like the poor man's function generator basically, but it does the job. I made some changes in this circuit here. It's not what it came from the shop directly, so I changed some things here, and now it does provide a good sine wave of 1 volt peak to peak. So I just need that, nothing else. So 1 kilohertz, 1 volt peak to peak feed in signal, and I'm going to be testing it with this oscilloscope. It is pretty good oscilloscope for this. I mean, like, it's enough for this. And I have this power resistors also. These are 8 ohms 100 watt resistors. I have couple of this, so we are going to be easily testing it with 8 ohms or 4 ohms. Okay, now let's do some basic calculation of how much supply voltage we'll be needing to power this amps to get 40 plus 40 watts of output. So we're just gonna take this out. So ideally, if you see, it's a very easy calculation. P out is basically V RMS squared divided by resistance. So P out here we know it's 40 watts. Again, I'm saying this is RMS output of the amplifier. We always measure the output power of the amplifier in RMS. V RMS we are yet to find, and R is we know 8 ohms. So V RMS is basically root over of 8 into 40. So it's basically coming close to root of 320. I just grab the calculator in here. So just root of 320, it's coming as 17.8. So I'll just say apparently 17.89 volts. Now we need to find the peak to peak voltage. So peak to peak is basically um, 2 into root 2 into V RMS. So whatever it came into 2 into root 2 is 50.6 volts. Now we have to be we have to know that this is basically the plus minus of the peak. That's why it's peak to peak. So if we say it's divided by 2 is 25.2. So basically V peak is plus minus 25.3 volts. That's the apparent thing. Now if you picture this, it will be basically coming as, suppose this is the driving wave, this is 0 volts, and this is the signal we are getting from the output of the amplifier. So this is where V peak comes in. This is say 25.3, and this is where this is plus, this is negative V peak. This is where minus 25.3 comes. This is where the RMS voltage comes, which is basically plus 17.8, and this is minus 17.8. So I just drew the calculations in a more neat manner. So this is going to be the output from the amplifier. This is not the voltage that we need to drive or to get the 40 watts of output. This is what is the output of the amplifier. Now we need something which is at least more than 4 volts from these two voltages. So suppose we will have as 25.3 plus, I'll say plus minus 4 volts, which is say 29.3 volts. So this is going to be the supply voltage to the amp. Now now to get this is DC voltage plus minus. The transformer we'll be needing is going to be, say, AC is 29.3 divided by 1.414. Again, whatever I'm calculating is just to give some or get some basic idea about how much is going to be the power or the voltage that I'm going to get 40 watts out. This is not the exact calculation because there will be line regulations, there will be a lot of different other parameters to get the exact value in here, but this will give you some basic idea about how much it's going to come. So if I just get the calculation in here, 29.3 divided by 1.414, it's 20 volts. So yep, so close to 20 volts, basically 20.7 volts. So I'll just say 20 volts. So what the transformer that we'll be needing is 20. Well, as I said, there will be diode drops also when you are rectifying this, but this is what we are going to get. So the say the transformer is we're going to need is 20 to get at least 40 watts. It's going to be definitely lesser than that, but we are going to get close to 40 watts. And for 15 watts of output, same equation. So if I just do it in a fast way, it's basically going to be, say, again 8 ohms is what we are using, so VRMS is root over of R, that is 8 into 15, which is going to come as 15 into 8 is 120, and root of 120 is 10.95. I'm just going to take as 11 volts here. Again, this VRMS, peak to peak is 2 into root 2 into 11 volts. Basically it's going to come as peak to peak is going to come as 11 into 2 into root 2, that is 31.1 volts. V peak is by 2, that is 15.5 volts plus minus. That is what we're going to need here. Now again, this is the output of the amp. This is not the supply. So here we just the supply of it. So Vs, or the supply, is basically say plus minus 15.5 volts divided by 1.414. Sorry, I'm doing a mistake here. So it's going to be basically Vs is going to be, the worst case scenario is 15.5 volts plus minus 4 volts. So Vs is going to be plus minus 19.5 volts. Yeah. And the AC supply, say VAC, is going to be 19.5 divided by 1.414 is going to be near about 13.79. So we can easily use a transformer of 30 to get output of close to 15 watts. To give us 15 watts of output, this gave us 40 watts of output. So this is what we're going to need. This is what we're going to need. Definitely there is another parameter in transformer which is more important than this, is the current rating. So normally what we would say is, suppose you are outputting 40 watts here. So basically we will do is, basically we are having a stereo amp, so 40 plus 40, which gives us 80 watts. We are going to double it, it's going to 160 watts, and we need something of 200 watts basically to be in the safer side for only this 40 watts of output. And here we need 15 plus 15, which is 30 watts. We're going to double it, 60 watts. So let's say some close to 300 watts of power we are going to need. So basically we will just have a core of which can produce something of 300 watts, and yeah, we'll easily get this figures. So I think that's it for today's video. I will link the person's number in the description from whom I have got this really great quality woofers and tweeters. In the next video, maybe when we will do the testing, I'll also link the person from whom I have got this and this chips. So yeah, I think first in the next video I'll be testing this TA2050 ICs in this board, and maybe this also, this bridge amp also with a 12012 or a 13013 transformer supply. So yeah, definitely I will say the thing which all the YouTubers say in the last: please do like, share, and subscribe. And yeah, we'll see you in the next video.